this video, I'm going to continue working on the focused practice questions. So let's focus. This is for grade 12 general. When connecting an ammeter, where should it be placed in the circuit? I mentioned it in the previous video, but I'll tell you again quickly. If you have a component that you want to measure, you will put the ammeter next to it in the same path as the component. It must be there so I can measure the current flowing through the ammeter, and that will be the same current flowing through the component. So it should be in series with whatever you're trying to measure. So this next one is asking when a fuse blows. Again, I did talk about this in the previous video as well. Just to remind you, a fuse is designed to break when there's too much current flowing through it. So in this case, we have a small thin wire which will melt, and it will protect the circuit by blocking the current from flowing through it. It blocks the current, so it becomes an open circuit then. And you can just replace the fuse, which is much cheaper than replacing your whatever you're using, your components. Which device is used in wet or damp environments? You may have noticed this in your home when it's stormy weather and it's raining, and all your electricity turns off. It's because the circuit breaker tripped. It got wet, and it gets wet, it will break the circuit. And all you need to do is reset it. Once it's dried up, you can just flip the switch, and you can get your current running again. So that's a circuit breaker. Refer to the answers here, very nice. What should the voltmeter reading be? Okay, so we have 27 volts, and this is one resistor here. There is nothing else shading the resistance, so he will take all of the energy. So this voltmeter is reading the energy he's taking, so that's just going to be 18 volts. It's just that, there's nothing else. If there was 2, you'd do the voltage divider. Now, ammeter reading, that's fine, we can find it. It's just V over R. And I've got 27 divided by 18. 27 over 18, I believe, 27 divided by 18, calculating this in my head, is 1.5. 27 divided by 18 is 1.5. Very good. 1.5 amps. Very nice. How much power is delivered to the resistor? Well, there are 3 formulas we can use for power, and you can just pick any one you want, and you'll get the same answer. We have PIV, we have PIR, and then we have PIVR. P equals V squared over R. I calculated I might have made a mistake in my calculation, so I would probably prefer to use the voltage and the resistance because that was given. I can use this one. You can do them, you'll get the same answer. So I will do P equals V squared over R. 27 squared divided by 18, and let's try it. 27 squared divided by 18. 27 squared by 18. I should get about 40.5 watts. That's the unit. Just to double check, I could do I times V, 27. I could go ahead and try it. Let's try this one just to see. P equals IV. Why not? Same thing. P equals IV. I'm going to do 1.5, and I'm going to multiply that by my 27. And in my calculator, I get the same answer, 40.5. There you go. So use 2 ways you can do it. Well, technically 3. But pick one and do it. That's all. Now, how much energy is delivered to the resistor per hour? So we know from before that energy is power multiplied by time. E is PT equals P multiplied by time. I just found my power both ways. I will do it once, 40.5 watts. I'll probably remove that so you don't get confused. Why did I do it twice? Multiply that by hour. Hour's not good. It must be in seconds. So if I want to get 1 hour and I want to put it into seconds, I will take my 1 hour and I'm going to multiply by 60 to put it into minutes because there's 60 minutes in an hour. Then I'll multiply by 60 again to get it into seconds. 60 times 60, that will give me how many seconds are in 1 hour, and that is 3,600. So I'll multiply by 3,600. And then, putting that in my calculator, let's see what we get. 3,600, I will get a big number. That's a very nice number. Okay, let's write it. 1, 4, 5, 8, 0, 0. And this is now energy, so that's joules. Amazing. Okay, answer all the questions. If instead the power source is 9 volts, that seems like extra work for nothing. If it was 9 volts, so replacing this for 9 volts, you need to do the same thing again. Voltmeter, ammeter, power, energy. I can let you try that. The voltmeter will still be 9. The current will be 9 divided by 18. The power, is it asking for power? Yes, it is asking for power. So then you'll do the same thing. Pick one of the formulas, V squared over R, 9 squared over 18. Energy, power times time, it's the same stuff. So I'm going to save myself some time and you some time. You can try it yourself. This one over here, 3 resistors are connected to this battery shown in the figure below. Find the total resistance. Very nice. This is a parallel circuit. As you can see, there are 3 parallel lines. So I need to do 1 over R equals 1 over R plus 1 over R. How many is there? There's 3 plus 1 over R. 3, 2, and 1. So what I'm going to do is, I know a little trick. I can actually just directly find R rather than flipping it afterwards. I can just find R by using a little bracket. I will do 1 over 4 plus 1 over 3 plus 1 over 12 to the power of minus 1. Putting that into my calculator, directly I'll get my answer. So if you were to stick that in your calculator, you should hopefully get 1.5. 1.5 ohms. Apologies for this creaky table. I'm not going to use this classroom again. It's really annoying. Now, find the total current in the circuit. The total current is V over R total. I total is V over R total. So all the totals. 15 is the battery. It says right here 15 volts. Divide that by what I just found, 1.5. 15 divided by 1.5, you will get 10 amps. That's to find the current in a parallel circuit. Now in this another parallel circuit, we define the total resistance. So this is 2 ohms, and this is 4 ohms, and this one is 4 ohms. How did I know that? Well, I read the question, right? There we go. And the battery is 12 volts. I like to label so I can see what I'm doing. Find the total resistance, same thing. I'm not going to write the formula numbers answer. You should in your exam, but I'm just going to do it because I'm using a mouse and it takes forever. So I'll do 1 over 2, 1 over 4, 1 over 4, minus 1. Sticking that into the calculator, you will get your answer. And you will find that this should be 1 ohm. Very nice. You will get 1. Find the reading of the ammeters A1 and A3. Okay, so we can do that. A1 is connected to the battery. A1 is connected to the battery, so that's the total current flowing through it. And then it splits into the 3 separate sections. So the total current flowing through here will be I equals V over R. V over R, 12 over the total resistance was 1. 12 over 1, that will give me 12 amps. That is the current flowing through A1. So I will call this A1. Now, for A2, what is that connected to? Well, that is connected to this R3. A2 is connected to R3 only. So I need to find the current through R3 only. I will do V over R3 only. Over here, I'll write total. Why not? This is R3. This voltage is connected to all 3. And remember, in parallel, the voltage is the same. Same rule applies. So 12 volts will be in this one. 12 over 4. 12 over 4, or 8, 12, that is 3 amps. You can do it for each one, and you will find that they all add up to 12. They add up to the total. Find the energy dissipated in 4 seconds. So we can find it. E is P multiplied by T. We don't have the power. I can find the power. What I can do is use one of my formulas. I have V, I have R. I can go back and just do the same thing. V squared over R. Multiply that by the time, because I'm multiplying by time. So let's try it. You will get 12 squared divided by R. So the R is, in this case, 4 ohms. And then I'm going to multiply that by the time it takes to get there. So the time, it's going to be 4 seconds. So 12 squared over 4 multiplied by 4, well, that will just give you, let's find out right now. 12 squared divided by 4 multiplied by 4, 144. 144 joules. That's how you will get this one. And then over here, we're going to find what's true about these 2 light bulbs. So this is a parallel circuit. Think about the rules for parallel. The current will come out here and it will split between the components. The current is shared between them. This will be the I total coming in, and this will be I1, and this will be I2. I1 plus I2 will be the total current. So A and B are wrong. I1 plus I2. This looks good, this looks good. Voltage, as from before, it's the same in parallel. Voltage is the same. So this is good. C is the best answer. If this is 10 volts, that'll be 10, that'll be 10 as well. The energy delivered is the same. Okay, so now we'll look at this again, adding more resistors. A third resistor is adding. So because of the formula 1 over R, 1 over R, adding an extra resistor will decrease the resistance in total. It's R divided by the number of resistors, if they're equal. If they're not, it doesn't matter. The point is the resistance will be less. These resistors don't change, by the way. The total resistance changes. The potential difference across the resistors, well, now we're asking about the potential difference, which is the voltage. And as you know, the voltage in parallel doesn't change. They will remain the same for this. The voltage will stay the same. The total resistance will decrease. That's fine. Total resistance will decrease, which means the total current will increase. If I have less resistance, I can have more current flowing through it. It makes sense because then there's more paths for the current to travel, so it's easier for it to move around. In this one, we have a bit of a mixed circuit, so I'm going to combine mixed circuits in my next and hopefully final video. Thank you.